Hello there and welcome to the BedTime Story Channel. Here's a deep, richly detailed look at ocean mysteries, the strange, wonderful, unexplained, and still unseen phenomena of the seas, running through many kinds of mysteries, from biology and geology to history and myth. You stand at the edge of the vessel's open hatch, the sea yawning out before you, glassy and calm under the soft light of the moon. A salty breeze lifts, brushing your face as if inviting you closer. The surface hides everything. The thousands of meters of water below, the canyons, the ridges, the trenches deeper than any mountain is tall. It's quiet, peaceful, but what lies beneath is anything but still. You step into the submersible, sleek, domed, pressurized. The hatch seals with a hydraulic hiss. Lights flicker on, illuminating the control panel and the dim interior. Around you, reinforced glass curves like the shell of a beetle, offering a view into blackness you're about to enter. With a low mechanical hum, you begin your descent. Within minutes, the colors vanish. Sunlight, which reaches only about 200 meters, is gone. You're descending into the twilight zone, a layer of dusky blue, where even the strongest sun cannot penetrate fully. This is the mesopelagic layer, from 200 to 1,000 meters down. You're sinking through it slowly, silently. Already, you begin to feel the difference. Small flashes blink in the distance, like fireflies. Shapes flicker. You're not alone. You pass a school of lanternfish, tiny things, each bearing glowing organs that pulse with cool light. Their purpose? Perhaps to attract mates, perhaps to lure prey. Or maybe no one really knows. That's part of the mystery. In fact, most of the creatures you're now passing are rarely, if ever, seen alive by human eyes. Some don't even have formal names, just specimen numbers stored in remote databases. A shadow darts past your viewport. You whirl, trying to follow it. Nothing. You realize now how limited your vision is. Just a cone of visibility from the submersible's forward lights. Beyond that, pure blackness. Any number of things could be floating just meters away, watching. Pressure increases. By 1,000 meters, the weight pressing against the hull is over 100 times atmospheric pressure. Every square inch of the sub's shell must resist thousands of pounds of crushing force. Out here, life has adapted in unimaginable ways, and you, protected in your tiny metal cocoon, can only glimpse them through glass. You descend past the last rays of sunlight, entering the midnight zone, the bathypelagic layer. No light has ever reached here naturally. Yet somehow, creatures thrive. In the beam of your lights, you catch sight of a transparent octopus, nearly invisible, except for the flicker of internal organs. Its eyes glow like opals. Nearby, a siphonophore trails glowing tendrils dozens of meters long. It's not a single creature, but a colony of organisms moving together like a ghostly train. Your ears pick up faint sounds through the ship's hydrophones, a rhythmic knocking, distant pulses, low-frequency groans, as if the ocean itself is breathing. Not all of these sounds are known. In fact, some have been recorded for decades and remain unexplained. Low, mechanical, haunting tones that scientists nickname after what they resemble. The bloop, the whistle, the upsweep. No one knows what caused them. Some say they're geological, the shifting of the seafloor or massive undersea landslides. Others suggest large animals, species so vast and deep-dwelling we've never seen them. Some of these sounds are so loud they could be heard across entire ocean basins. The vessel shudders slightly as it crosses a thermocline, a layer where water temperature drops rapidly. It's icy cold now, near freezing, but your systems hold. You think about the creatures out there, living in total darkness, in cold, that would kill you in minutes. Their bodies often lack pigment. Many don't have eyes, or if they do, they're adapted to detect faint light from bioluminescent flashes. Some make light themselves, using chemical reactions to glow in patterns and pulses. Why? Maybe for mating, maybe as camouflage, maybe even to communicate in ways we don't yet understand. A faint shape begins to emerge ahead. You lean forward. At first it seems like just more darkness, but then you realize it's an abyssal plain, a flat, almost featureless expanse of fine sediment stretching out in every direction. It lies at nearly 4,000 meters deep. You're now on the floor of the ocean. Here, the silence is different, thicker, heavier. It's the kind of silence that seems to listen back. Your lights reveal small marks in the sand, tracks. Something has passed this way. Maybe a creature, maybe a current, maybe a machine long ago lost to the deep. There's no way to know for sure. You pass over what looks like a rusting object, half buried. A piece of wreckage, a probe. There's no signal. The ocean keeps its secrets well. Your sub navigates toward a rocky outcrop ahead, rising slightly from the otherwise flat plain. It's covered in filter feeders, crabs, strange anemone-like creatures. A faint current tugs at them, stirring their tendrils. One of them pulses with faint blue light as you pass, as if acknowledging your presence. There's movement up ahead. You guide the sub cautiously toward it, adjusting the focus of your camera. A large, slow shape glides just past your beam. It's almost graceful, pulsing gently as it swims. Its outline is unfamiliar, not a fish, not a ray. You follow, but it disappears behind a rocky pillar. A small vibration shakes your seat. A tremor. The seafloor sometimes shifts without warning, part of the tectonic processes you'll explore later. You check your depth gauge. Nearly 4,300 meters. You are deeper than 99% of humans have ever gone. Suddenly, you see it. A glowing chimney rising from the seafloor, shimmering in your lights. Smoke-like clouds are billowing out of its top, black and thick, but not smoke at all. It's superheated water, laced with minerals, blasting from deep within the Earth's crust, a hydrothermal vent. And around it, life. Dozens, maybe hundreds, of tube worms cluster around the vent like flowers blooming from rock. They are blind. They have no mouths. Yet they thrive. Symbiotic bacteria inside them feed on chemicals in the vent water, transforming poison into energy. It's a whole ecosystem independent of the sun, independent of everything we once thought necessary for life. You stare in silence. Here, in the cold, lightless depths of the world, life is rewriting the rules, and you've only just begun to understand what it means. This is not just descent. It's a passage into wonder. The hydrothermal vent pulses behind you, casting shifting shadows across the ancient seabed. The plume of mineral-rich water continues to rise, feeding clouds of bacteria and creating a shimmering heat halo in the freezing deep. Your submersible drifts slightly with the current, and as you pull back from the vent chimney, a vast emptiness spreads out before you once more. You switch off the external floodlights, one by one, until the darkness returns. And then, light. Not from your sub, but from the ocean itself. The blackness flickers with pulses, waves, and patterns of pale blue, green, sometimes even red and violet. They're not random. They ripple like coded messages across invisible fields. You've entered the realm of bioluminescence, the natural light produced by living things. Here, in the midnight zone, where no sunlight reaches, light becomes language, lure, defense, and art. It is the heartbeat of an unseen world. A small fish drifts by, pulsing softly from glands along its side. A burst of pale green light erupts as it senses you. In seconds, the creature vanishes into the black, leaving only its glowing trail behind, like the smear of a comet. You float in silence, watching these secretive flashes, a Morse code you cannot yet read. You remember what researchers have said. Most of the animals in the deep sea use bioluminescence, yet we don't fully understand how or why. Some light up to confuse predators, some to attract prey, some use it to communicate across the void. Others may mimic stars to disguise their outlines from creatures lurking below. These are camouflage techniques honed over millions of years in an environment where even the dimmest glow is a beacon. You move deeper along the slope of a seamount, the towering remains of an extinct undersea volcano. This one never broke the surface. Its peak is still more than 2,000 meters beneath the waves. Its flanks are jagged, eroded by ancient currents. Coral-like structures cling to its sides, feeding on falling detritus. The marine snow of dead organisms, particles, and mystery dust that constantly rains down from above. And then you see it, a curtain of light swaying across the rocks. Not an animal, but a siphonophore, one of the most bizarre creatures ever encountered. It stretches like a living thread, glowing faintly along its entire length, tens of meters long. But it's not a single animal. It's a colonial organism made up of many smaller units, each specialized, each playing a different role: propulsion, digestion, defense. Together, they move as one, a shape-shifting, drifting ghost of the deep. Some siphonophores can grow to be among the longest animals on Earth, even longer than blue whales. Yet they are fragile, near impossible to study alive. Most break apart under collection. So many facts about their life: what they eat, how they reproduce, how they build their structures, are still guesses. Your lights catch another shape, a creature hanging motionless in the water. It's large, gelatinous, almost transparent, like a bell filled with stars. You found a comb jelly, or ctenophore. Unlike jellyfish, it doesn't sting. Instead, it glides using rows of tiny hairs, cilia, that refract light in rainbows. It seems like a drifting chandelier, glowing softly in the currents. Suddenly, a much stranger form appears. At first, you think it's a shadow, but it resolves into an animal, unlike anything else. It looks like an upright sheet of rippling silk, hovering vertically in the water column, almost immobile. Then it twists, its entire body undulating in a single graceful wave, and glides away. You've just witnessed a deep staria jellyfish, extremely rare. Some of these have only ever been seen once or twice. They have no long tentacles, no pulsating movements, just a ghost-like membrane that expands and contracts like breath. They are some of the deepest living jellyfish known, and no one really knows what they eat, or how they mate, or why their form is so radically different. You guide your vessel around a rocky spur, and suddenly find yourself facing a gulper eel. Its body is thin, sinuous, serpentine, but its jaw opens wide, impossibly wide, like a net. This fish doesn't chase prey. It swallows whatever it comes across, sometimes creatures half its own size. But strangely, it has tiny teeth, barely useful for biting. You suspect its enormous jaw is more like a trapdoor, a mechanism to engulf prey quickly in the darkness before it can escape. Behind it, more life. A school of small hatchetfish flashes by in a synchronized burst of light. You notice that their undersides shimmer faintly. These fish glow downward to match the weak light filtering from above, erasing their own shadows. To predators below, they become invisible. This is counter-illumination, one of the most advanced camouflage strategies in the animal kingdom, and it evolved in total darkness. You check your depth, 5,200 meters. You are now approaching the abyssal zone, and things are changing. The animals here move more slowly. They conserve energy. Many are sedentary or drift aimlessly. There's little food this deep. What reaches them falls from above, and what doesn't must be hunted with patience. You see a sea cucumber moving across the seafloor with tiny tube feet. Then another, floating slightly above the sand like a blimp. Some of these creatures, scientists now know, migrate vertically, thousands of meters every night, following food. It's an unimaginably long daily journey, and yet they do it in silence for survival. And then, off in the distance, your spotlight catches something huge. It's not moving, not anymore. As you approach, the shape becomes clear, a whale fall. The skeleton lies in pieces on the seabed, the vast skull tipped sideways, the ribs rising like broken cathedral arches from the sand. A whale has died and sunk to the bottom. Here, even in death, it sustains life. Around the bones, scavengers gather, hagfish, rat-tail fish, isopods the size of your hand. Worms tunnel into the remaining flesh. Bacteria bloom on the fat-rich bones. Some of these organisms exist nowhere else. They evolved to survive solely on whalefalls. You pause to take it in. In a way, this is one of the ocean's deepest truths. Even in the most remote, cold, lightless places, life will find a way. Your sub hovers there for a while. You shut down the lights again. More bioluminescence. This time, it's all around, twinkling like a reversed sky. Creatures blinking in slow sequences or flashing like sudden lightning. Some glow continuously, others in pulses. You see shapes and trails, sometimes with rhythm, as if entire communities are speaking a visual language beneath your feet. Do they signal each other? Compete? Are there patterns we haven't yet deciphered? Some scientists believe we may one day decode deep-sea communication, perhaps even find social behavior among bioluminescent organisms. Others suggest it's all noise, all instinct. But one thing is certain, we are not alone in the dark. A final flicker crosses your viewport. Something long, coiling, maybe finned. You glimpse it for less than 2 seconds before it vanishes beyond your beam. No camera caught it, no sonar pinged it. Was it a giant squid? Was it something else? You lean forward into the darkness, heart beating faster. But it's gone. And you remember, 95% of the deep sea remains unexplored. You switch the lights back on. The vent is far behind now. Ahead, a rocky slope leads deeper, and deeper still. You decide to follow it. The slope beneath your submersible drops into a shadowed valley, a narrow gorge carved between two rising flanks of basalt. The seafloor here is not soft sediment, but fractured rock, as though the earth has split open. Your instruments flicker momentarily. Slight magnetic interference, unusual heat signatures. You've entered an active zone, though from the surface you'd never guess it. This is a region of hydrothermal activity, and something stirs beneath the stone. The pressure outside now exceeds 500 times the atmosphere at sea level. But your vessel is built for this. Deeper still, and you begin to see it. Faint distortions in the water, like heat rising from pavement on a summer day. These are not visual tricks. You are nearing another vent field, but not like the last. Your eyes widen as the scene unfolds. All around you, white pillars rise like the towers of a ruined city, tall, twisting, honeycombed with strange mineral textures. From their tops, instead of thick black smoke, wisps of milky fluid drift upward. These are not black smokers. You've entered the domain of white smokers, a different kind of vent, where water still erupts from below, but carries a lighter mixture of minerals, mostly barium, calcium, and silicon. The structures are paler, sometimes reaching several stories high, and then something stranger still. To your left, on a rugged ridge, the lights catch structures like spires, but with curves and undulations that look almost sculpted. They shine faintly, coated in calcite, as though dipped in moonlight. This is no ordinary vent site. Your depth gauge confirms it. This is the Lost City hydrothermal field. Discovered only in the year 2000, Lost City is unlike any other place on Earth. Here the chimneys are not built from sulfides like most vent fields, but from carbonate, the same mineral that forms coral reefs and limestone caves. And while most hydrothermal vents form where tectonic plates pull apart, Lost City forms on mantle rock, peridotite, exposed by tectonic uplift and altered by chemical reactions with seawater. This alteration, serpentinization, creates heat, fuels chemical reactions, and releases hydrogen and methane into the water. It's a process that might mirror the early Earth, when life first began. You drift closer. The spires are huge, some over 60 meters tall. Their walls are porous, honeycombed with microbial mats, strange crusts, delicate fans and tendrils. Bubbles of gas drift upward. You switch on the chemical sensors. Methane is present, along with hydrogen and trace hydrocarbons. This is not a volcanic system. There's no magma here. The heat comes from rock and water interacting far below the seafloor. Your lights pass over a cluster of microorganisms clinging to the warm rock. They're not like surface bacteria. These are extremophiles, organisms that thrive in high pressure, high pH, low oxygen, and total darkness. Some feed directly on the hydrogen and methane, using chemosynthesis rather than photosynthesis to create energy. These microbes are ancient in form. Some scientists believe they resemble the first life on Earth, tiny communities surviving in the cracks of an alien planet. And not just that. If such life can arise in a place like this, it could exist on other worlds, on Europa, Enceladus, or any ice-covered moon with water and rocky cores. You pause, watching the slow drift of gas and light. It is peaceful, but not dead. The whole field pulses with slow, secret life. The hydrothermal vents hum with unseen reactions. The warm water meets the cold abyss, creating dynamic flows. Small shrimp dart near the hottest jets, some with no eyes at all, sensing only heat. Crabs scrape bacterial films from the rocks. Eels slither through gaps in the mineral towers. Somewhere deep below, water is seeping into the rock, reacting, transforming, and then emerging here, changed, carrying the memory of Earth's interior. This field has been active for at least 120,000 years. Some researchers believe it may last hundreds of thousands more. Compared to black smokers, which can fizzle out in just a few decades, Lost City is ancient and stable, an oasis in the darkness. And still, we have barely studied it. only a handful of missions have visited Lost City. It lies in the middle of the Atlantic, far from coasts, in deep water. The cost is high, the risks are real. And yet, within this one ridge, there may be secrets to life itself. You turn to your instruments again. One of the sensors flashes, an unusual chemical signature. Could it be organic? A gas blend not yet documented? The thought hits you. We might be detecting molecules made by life, just not life we recognize. Scientists have long speculated that vent fields could support entire biospheres with alien metabolisms, perhaps even parallel lines of microbial evolution cut off from the rest of the planet. Because sunlight never reaches this place, its energy economy is entirely different. What if evolution took another path here? One not based on sugars and oxygen, but on methane and minerals. You steady your breathing. For a moment, it's like you're floating in time. Before life, before continents, before animals and plants, there were only oceans, and within them, places like this. And then, movement. From between two chimneys, a dark shape emerges. Broad, slow-moving, with long fins undulating like silk in a breeze. A deep sea skate. Its wings glide inches from the rocky outcrops. It doesn't seem startled by your lights. It's been here long before you, and will likely be here long after. Nearby, you see a cluster of eggs clinging to a vent wall. Translucent cases, pale yellow, gently swaying. New life growing beside the hot water and gas. Even here, at more than 700 atmospheres of pressure, things are being born. Your hydrophone picks up a low thrumming noise. Not mechanical, not from the ship. It pulses through the water like a heartbeat. You try triangulating it, but there's no source in view. Another mystery. Another sound from the deep that remains unnamed, untraced. You mark it for later analysis. You circle one last time through the forest of towers. Some are cracked and crumbling, others still venting heat. A few rise like curved blades, etched with white mineral veining. You wonder if anything has ever seen them besides the few remote submersibles and brief expeditions of human curiosity. The name Lost City feels apt. Not just because of the pillars, but because of what's hidden here. The possibility that life can arise from stone and seawater. That biology doesn't need the sky or the sun. That alien oceans across the solar system may be less alien than we think. You take one last reading. Then, quietly, you rise. The towers fade beneath you, shrinking into shadow. The sensors go quiet. The methane plumes thin and vanish. Darkness returns. Silent, absolute. But now, you carry a little of that place with you. Not just data, or video, or samples, but a sense that the Earth is stranger than anyone knows. As you ascend from the lost city, the spires fading into shadow below, you feel as though you're leaving behind something sacred, an ancient chapel of chemistry and stone. But the ocean is not finished revealing its secrets. Your submersible climbs a narrow ridge, cresting over a valley carved into the crust itself. The light from your vessel scans ahead, and there it is. A wall of darkness, rising higher than any mountain you've seen so far beneath the sea. But it's not a wall. It's the beginning of one of Earth's most dramatic and least explored landforms, the mid-ocean ridge system. Stretching over 65,000 kilometers across the globe, the mid-ocean ridges are the longest mountain range on Earth, mostly hidden from view, carved by tectonic forces over eons. You are drifting now along just one segment of this submerged spine, where two tectonic plates are slowly pulling apart, creating new seafloor in a process called seafloor spreading. You guide the sub along a deep gash in the earth, the rift valley that forms where the plates diverge. It's eerily quiet, yet the forces here are titanic. Basalt flows from fissures in the seafloor, cooling instantly in the icy water. You see pillow lava formations, rounded bulbous rock mounds that look like frozen balloons, testifying to past eruptions. The walls around you seem impossibly high, cliffs of solid rock that rise and fall like skyscrapers. On land, these were dwarf cities. Down here, they remain unnamed. As you hover near one cliff, your lights pick out curious features, smooth lines etched into the stone, curving patterns like ancient writing. You zoom closer and realize these aren't scratches. They're fault scarps, evidence of the Earth's plates grinding and shifting. Each small cliff marks a moment of release, an underwater earthquake that happens silently, unnoticed, beneath thousands of meters of water. You glance at the sonar. Deep below, there's a wide basin, perhaps a collapsed magma chamber or an old fracture, and something else, a strange echo. A shadow on the scan, a feature that doesn't belong. You bring the sub closer, sweeping your lights across the basin floor. For a long moment, there's nothing but sediment and stone. Then, as you round a sharp bend, you see it. A monolith. No, a stack of boulders? A pillar. You pause. It's too regular, too vertical. It rises out of the plain like a marker, maybe 4 meters tall. The stone is dark, nearly black, with an unusual smoothness. It's not volcanic. It looks placed. You scan it. No signal, no markings, but something about it tugs at you. A memory of old legends. You wonder, could this be a geologic coincidence? Or has it been touched by intelligence? You remind yourself, the ocean is full of false patterns. The human brain wants to find shapes, symbols, faces, but still, the mystery lingers. What else lies out here, in the unmapped vastness? You continue along the ridge, following the valley deeper into the unknown. The temperature drops. The terrain grows jagged. You begin to see signs of collapse. Massive boulders sheared from the ridge walls, lying where they fell. This is the result of tectonic violence. Undersea landslides that can trigger tsunamis without a single human witness. Some are so vast they can rearrange the seafloor for miles. Suddenly, your seismic monitor flickers. A low-frequency tremor ripples through the water. It's small, but unmistakable. You wait, breath held. Another jolt, then nothing. The Earth has shifted again, deep beneath the weight of its own crust. Out here, it happens every day, and no one knows. You resume your exploration and come across a field of fissures, some only inches wide, others deep enough to swallow your sub. Superheated water seeps from some of them, cloudy with fine minerals. These cracks are birthplaces where new ocean crust is forming molecule by molecule. Above you, a series of massive seamounts rise, submarine mountains that once may have been volcanoes. Some of them are still active, others lie dormant, cloaked in mystery. You steer closer to one, its flanks crawling with bizarre coral structures blackened by ancient lava. One of the most profound truths of ocean geology is now clear. The sea floor is constantly changing. It may feel static beneath the water, but it is not. It moves, it builds, it breaks. The ocean floor is alive in its own elemental way. And yet, we have mapped Mars more thoroughly than we've mapped the ocean floor. That fact returns to you as you pass another immense trench in the ridge, deeper than your instruments can currently measure. Only 20% of the seafloor has been mapped in high resolution. The rest is inferred from satellite altimetry, or not measured at all. You are floating in a landscape that, in many ways, still belongs to the unknown. A strange clicking sound filters through your hydrophones. You pause, trying to isolate the source. It sounds like distant metal tapping, almost rhythmic. Then a different tone joins it, lower, longer, like the groaning of a stressed beam. You're not near any equipment or known shipping lanes. No sonar contacts, just more ocean. You record the audio for later study. It reminds you of one of the great unsolved riddles of the deep, the unexplained underwater sounds. The bloop, the upsweep, the whistle, the train. Names given to strange, powerful acoustic events recorded by underwater microphones. Some are seasonal, some repeat annually, others have only ever been heard once. None have definitive explanations. Some suggest natural causes, ice calving, undersea landslides, gas venting. Others hint at living sources, perhaps whales or giant squid, or creatures entirely unknown. The bloop, for instance, was once believed to be biological in origin, so loud it could be heard across the Pacific. Later studies suggested an ice quake, but doubt remains. You listen to the faint pings and knocks echoing around the basin you now float in. They could be geologic, they could be mechanical, or something else entirely. In the pitch dark of the ocean, sound travels far, and what you hear is often stranger than what you see. Your vessel climbs another ridge and crests over a new horizon. There, ahead of you, is a sight both beautiful and unsettling. A submarine caldera miles wide. The collapsed top of a long-dead volcano. The walls are steep, pockmarked with vents and craters. In the center lies a plain of cooled lava, dull black, cracked like an ancient mosaic. The caldera is empty now, silent. But at some point in the distant past, it exploded with unimaginable force. These submarine eruptions may not shoot flames into the sky, but their power is just as vast, hidden under kilometers of seawater. Some undersea volcanoes erupt without anyone ever knowing. You feel the vastness of it, the isolation, the silence of ancient destruction, and the certainty that the ocean floor has shaped the earth in ways we still don't fully understand. You descend into the caldera, your lights catching glints of metal, old sensors possibly, or debris from past research missions. Or maybe not. A shape looms ahead. It looks artificial. Your heart rate picks up. You get closer. A sunken autonomous drone, its body twisted and corroded. No markings remain. It could be from a previous expedition, or from another nation's survey, or something else entirely. No one reported its loss. You make a note, capture the coordinates, and leave it undisturbed. As you rise from the caldera floor, the thought occurs. How many machines have been lost down here? How many were looking for answers and found only silence? The seafloor is a graveyard of experiments, of discoveries not yet retrieved, and of riddles still waiting. You turn the sub away from the ridge, moving now into deeper waters. The terrain is changing again, less volcanic, more sediment-rich, smoother. It looks calm, peaceful, but you know better. Beneath the silence, the ocean is always in motion, and somewhere ahead lies its deepest point. The vast plain ahead stretches out like an ancient desert, endless and silent. But unlike any desert on land, this one lies beneath nearly 11 kilometers of crushing water, in the Hadal Zone, the deepest region of the ocean, named after Hades, the Greek god of the underworld. You're entering the Mariana Trench, a place so deep that Mount Everest could be dropped into it and still be submerged by more than a mile of water. Everything changes here. Even light, pressure, and time feel different. Your submersible descends slowly, carefully. At this depth, the hull groans ever so faintly. Sensors are constantly monitored for stress. The darkness is complete. Your external lights reveal only a narrow circle, a tunnel of sight through the infinite black. This is Challenger Deep, the deepest known point on Earth. Only a handful of people have ever visited it, fewer than have walked on the moon. As you drift downward, the water grows heavier, not in any way you can see or feel, but by physics. At nearly 1,100 atmospheres, every square inch of your vessel is being squeezed by more than 16,000 pounds of force. The human body would be crushed in seconds outside the hull, and yet life persists. Suddenly, movement. In your beams, a translucent shape flickers and darts away. A Hadal snailfish, ghostly, soft-bodied, and nearly see-through. These fragile fish live at depths previously thought uninhabitable. Their skin lacks scales. Their bones are light, almost gelatinous. Their bodies have adapted to pressure by being flexible instead of strong. Their enzymes function under conditions that would destroy other proteins, and still, they live, feed, and reproduce in this frozen, eternal night. Nearby, you spot a clump of small amphipods, shrimp-like creatures scuttling across the sediment. Some of them are eating, but what? Then you see it, a jellyfish carcass, or what's left of one, a thick, soupy mass that fell from above. Marine snow, a constant rain of dead organisms, plankton, fecal pellets, and tiny detritus, feeds many of the trench's inhabitants. But now and then, something larger arrives, a squid, a shark, or a whale. These are known as food falls, and in the trench, they're rare and precious. Creatures here have evolved to detect the faintest chemical traces of such events from kilometers away. Some travel huge vertical distances to reach them. Others simply wait, conserving energy until opportunity literally falls from the sky. But Challenger Deep is not a lifeless pit. It's not a graveyard. It's a wilderness, largely unseen and unknown. As your lights sweep across the muddy seafloor, you begin to see signs of more life. Burrows tracks, tiny mounds. Something down here is stirring the sediment, feeding, moving, hiding. You adjust the camera's angle and zoom in. A small, eel-like fish glides into view, its eyes pale, its jaw oversized. It freezes when illuminated, then vanishes into the gloom. Some Hadal creatures may be endemic to single trenches, entire species that exist nowhere else on Earth, not even in other deep-sea basins. And because trenches are separated by ridges and other seafloor features, they act like islands. Over time, life in each trench may evolve differently. You're reminded of a concept in biology, adaptive radiation. Like the Galapagos Islands or isolated cave systems, the trench may be an evolutionary lab full of creatures shaped by intense pressure, extreme darkness, and scarce food. You pass over a long fissure, its edges jagged, its interior vanishing into blackness. This is no ordinary crack. It's a scar left by tectonic forces that continue to shape the trench. The Pacific Plate is slowly diving beneath the Mariana Plate, creating the trench over millions of years. The process continues even now, silently, beneath your feet. As you ascend from the trench, leaving Challenger Deep behind in the crushing silence of the abyss, your thoughts drift to the peculiar paradox of the ocean. The deeper we go, the more we encounter the unknown. But the shallow waters, too, guard their own secrets. The twilight zone, just a few hundred meters below the surface, holds riddles as enigmatic as those in the Hadal depths. This is the mesopelagic zone, where sunlight begins to die, fading into deep blue, then into nothing. It's a region that stretches from around 200 to 1,000 meters below the surface. There's just enough light to create contrast, but not enough for vision to be reliable. Here, in this dim blue-grey world, camouflage, deception, and vertical migrations reign. You guide your submersible laterally now, maintaining a relatively stable depth as you enter one of the most densely populated layers of the ocean. By biomass, if not by diversity, you are in the realm of the deep scattering layer. At first glance, the water appears empty, but your sonar tells a different story. A massive layer of sound-reflecting organisms hangs in the water column, so dense it was once mistaken for the seafloor by early sonar systems. It stretches across entire ocean basins and rises and falls with the sun in what may be the largest migration on Earth. You adjust your lights, dimming them, and then, suddenly, the ocean seems to move. A wave of life passes before you. Lanternfish, countless in number, with glowing photophores arranged along their bodies like constellations. They rise from the depths each night to feed closer to the surface, then descend again before dawn. With them come bristlemouths, hatchetfish, and cyclothone, tiny, fanged, glassy creatures whose names rarely make headlines, yet who may be the most abundant vertebrates on the planet. Some scientists estimate that these fish outnumber all other fish in the ocean combined. But few people have ever seen one alive. As you drift through the twilight zone, your sub encounters a living tapestry of flickers and glows. Counter-illumination is everywhere. Organisms emitting light from their undersides to match the fading daylight above. The effect is stunning. To a predator lurking below, these fish vanish into the background. It's not just camouflage, it's an active invisibility cloak, a strategy evolved by necessity in a place where being seen is often fatal. You pause beside a large, slow-moving jellyfish, its bell pulsing gently. Around it swarm parasitic amphipods, riding its current, nibbling on its tissues. It's a floating micro-ecosystem, a fragile satellite adrift in the dimming light. You remember something critical. The twilight zone is a crucial carbon sink. Every day, billions of fish and zooplankton migrate upward to feed, and when they return to the depths, they take with them carbon in the form of waste and dead material. This biological pump helps regulate Earth's climate. And yet, we are only beginning to understand it. Your attention is drawn to a flicker far below. It moves unnaturally, jagged, sharp-angled. You adjust course. A squid, perhaps? Closer now, the lights reveal a shape so strange it seems fictional. A glass squid floats in the current, its body nearly invisible except for the glowing organs inside. Some species have eyes of different sizes, adapted to scan both above for silhouettes and below for bioluminescent glimmers. The squid pulses softly, a soft jet pushing it through the water. You realize you've startled it. With a sudden, radiant flash, the squid flares like a firework, blinding your senses momentarily. When the light fades, it's gone, vanished into the layered darkness. This is what many twilight creatures do. Not just glow to be seen, but glow to disappear. Some release bioluminescent ink, confusing predators with glowing decoys. Others emit short, sharp bursts of light to blind or disorient. Evolution in the twilight zone is about disguise, timing, and motion. Predators learn to sense the rhythm of the water, the slight distortions of a moving shadow, the faintest trail of heat. Prey evolved to break patterns, to drift rather than swim, to be 1 second late or 1 inch off center from expectation. As you ascend slightly, you notice a subtle current pulling east. This is part of one of the many subsurface currents that move heat, salt, and nutrients across the globe. They're invisible rivers within the sea, steering plankton, larvae, and nutrients over thousands of kilometers. Without them, tropical oceans would stagnate, and polar seas would starve. You pass a salp chain, dozens of clear barrel-shaped creatures linked together like a gelatinous train. These tunicates filter microscopic algae and reproduce rapidly. Some can double their population in a day. While they may look primitive, they are more closely related to humans than to jellyfish. You watch them move in a slow, pulsing rhythm, silently vacuuming the water around them. And then, a strange anomaly, a sphere, bobbing just out of reach. Not natural. You bring the sub closer. It's a drifter buoy, likely deployed by a research project. The tag is faded, the electronics long dead. It's encrusted with gooseneck barnacles and long fronds of algae, a floating island in the open sea. Around it, a small school of fish hover, finding shelter in the shadow. This is a glimpse of the Newston layer, the very top layer of the ocean, where many organisms and even floating debris become microhabitats. And it's here, in the upper twilight and epipelagic zone, that you begin to find traces of human life, or more often, human waste. A drifting plastic bag, trailing like a jellyfish. A broken fishing line, tangled with kelp. A bottle, its label faded, its contents unknowable. In these depths, the boundary between nature and refuse blurs. Organisms cling to trash as though it were driftwood. Microplastics, invisible to the eye, may already be inside the fish you've seen. You remember the Great Pacific Garbage Patch, a region in the North Pacific where currents trap millions of tons of floating plastic. It doesn't look like an island of trash. It's more like a diffuse floating soup, nearly impossible to clean. And below it, researchers have found plastic particles falling like snow, infiltrating ecosystems far beneath the surface. Even in this deep blue expanse of beauty and balance, the touch of humanity is evident. But there's also resilience. You pass a giant Larvacean, filtering water through a mucus house the size of a beach ball. When the structure clogs, it's shed and sinks rapidly to the seafloor, carrying with it particles of carbon, pollutants, and even plastic. This is a reminder that the ocean has mechanisms to clean itself, to capture carbon, to heal, if given the chance. As you continue your journey through the twilight zone, it becomes clear. This isn't just a transitional space between the surface and the deep. It is a world unto itself, full of constant motion, endless mystery, and vital importance. And much of it remains unmapped, unsampled, and misunderstood. From this layer alone could come new medicines, new materials, and new models for sustainable ecosystems. But it's fragile, and already fishing companies eye it for mass harvesting of mesopelagic species, lanternfish by the ton, for protein and feed. But what happens if we strip it bare, not knowing what role these creatures play in climate, in food webs, in ocean health? You drift a little longer in silence, surrounded by flickers, by watchers in the dark. And you realize the twilight zone may not be as dark as it seems. It's simply lit by another kind of light, one we're only beginning to understand. The surface seems calm now, deceptively so. Gentle waves lap at the shoreline behind you, but as your submersible pivots away from the continental shelf and begins to move farther along the coastal boundary, you understand something instinctual. This region is not static. It is in flux, always changing, always adjusting to forces from above and below. And here, where land and sea collide, is one of the ocean's most mysterious realms, the intertidal zone. You guide your submersible close to a rocky outcrop during low tide. The water is shallow, the bottom uneven, and the zone alternates between ocean and air every few hours. Life here is adapted to extremes: crashing waves, exposure to sun, abrupt temperature swings, and the relentless hunt for food during brief windows of time. Clinging to every surface are barnacles, mussels, and sea stars. Small crabs scuttle sideways across slippery rocks. Sea anemones close tightly as the water recedes. This place is wild, rugged, and shaped by rhythm, the tidal clock, set by the moon and the Earth's rotation. You watch as a limpet, no larger than a fingernail, crawls slowly across the rock. At first glance, it's nothing unusual, but it knows the tide better than any computer. It returns to the same exact spot each time the tide goes out. It's home scar, a perfect fit worn into the rock over years of microscopic movement. Then there's the chiton, a creature armoured like a medieval knight, with 8 plates and a soft, muscular foot. It too knows the timing of the sea and moves with purpose even in these chaotic margins. You adjust your depth slightly, moving down a metre or two to observe a tide pool, a shallow basin carved into stone, temporarily separated from the greater ocean. Within it is an entire microcosm. Small gobies dart between rocks. Algae sway lazily, while nudibranchs, sea slugs of indescribable colour, graze on sponges and anemones. A single octopus, no larger than your hand, changes colour and shape in an instant to blend in with the pebbled floor. To the casual eye, it's just a puddle left by the sea. To you, it is a universe in miniature. The tide begins to rise again, and you retreat with it, gliding along the coast where ecosystems shift rapidly: mangrove forests, salt marshes, estuaries, and lagoons. These are transition zones between salt and fresh water, between sea and land, and each hosts mysteries as profound as any abyss. You find yourself approaching a dense thicket of mangrove trees, their roots tangled like knotted rope beneath the surface. Fish weave through the underwater network, hiding from predators. Juvenile sharks, no longer than your arm, patrol the shadows. These are nurseries, safe havens for the young of many species. Mangroves are extraordinary. They filter salt, stabilize coastlines, and store immense amounts of carbon, locking it away for centuries in thick, oxygen-poor soils. Yet they too are under threat. Coastal development, pollution, and sea level rise have decimated their global range. But even here, where the water is brown and silty and the land is close, the ocean's mysteries persist. Your instruments ping. Something large is nearby, moving fast through shallow water. You move quietly through the mangrove channel, parting floating leaves and soft debris. Then, like a ghost, it passes. A manatee, slow, ancient-looking, gentle. It barely notices you, grazing on seagrass with a kind of peaceful focus. You hold still, marveling at the paradox of such large creatures thriving in such narrow, fragile waters. But it's not just manatees. In other parts of the world's coastal shallows, rare and elusive animals appear and vanish like myths. The vaquita, a critically endangered porpoise seen only in the Gulf of California. The dugongs of the Indian Ocean. the mysterious beaked whales which seem to evade detection as if by choice. You realize that some of the ocean's secrets aren't hidden by depth, but by movement, camouflage, and sheer unpredictability. Your journey now takes you into estuaries, where freshwater rivers merge with the salty ocean. The water here is brackish, its salinity constantly shifting with the tide, rainfall, and season. These estuaries are among the richest ecosystems on Earth, yet also among the least protected. From your sub, you watch schools of young fish sheltering among reeds and eelgrass. You see shrimp, mollusks, and flatfish nestled in mud. And you note the sharp line where murky river water meets clearer ocean water, like a river within the sea. Estuaries are filters, buffers, lungs for the coastlines. But they are also highways of migration. Many fish, like salmon, must pass through them on their way to spawn upstream. Eels, in the opposite direction, travel from freshwater rivers out into the deep ocean, sometimes across thousands of miles, to breed in places we still haven't definitively located, like the Sargasso Sea.